Good morning, everyone. Good morning. Am I audible?
Good morning, ma'am.
Good morning. Still 29, 29 participants. We'll wait for just 2 minutes, then we'll start the lecture. Let everyone join. I was looking at the assignment. Only 57, 59 has given the assignment. Remaining have not submitted the assignment. Any particular reason for not submitting the assignment? कल लास्ट डेट था असाइनमेंट सबमिट करने का. सिर्फ 59 लोगों ने सबमिट की है. आप लोग जो ज्वाइन किए सभी ने सबमिट किए असाइनमेंट?
Yes, ma'am.
Yes, ma'am.
सभी ने?
Yes, ma'am.
Yes, ma'am.
ओके. सो स्टिल 37. अभी पूरी आपकी क्लास की स्ट्रेंथ कितनी है? 100?
100.
ओके. 97 लोग ही ज्वाइन किए. 3 लोग ज्वाइन नहीं किए है क्लास को. मे बी आई डोंट नो व्हाट इज द रीजन. ओके. कल तक के जो पढ़ाया उसमें कुछ डाउट?
No, ma'am. No, ma'am.
Okay. So we'll start with directly condensed phase rule, and we will go to two component system with partially miscible liquids. And I hope आज हमारा ये complete हो जाएगा. Okay. What are condensed systems? कोई एक answer करो. What do you mean by condensed systems? इस पर क्वेश्चन आता है. आप लोग क्वेश्चन लिख के रखो नोटबुक में. Explain condensed phase rule. Yeah, define condensed phase rule. Now, who will tell me what is condensed system?
Madam, it is a single component system and the maximum number of degrees of freedom is 2.
It is a single component system. One second. It is a single component system. आगे बोलिए.
The maximum number of degree of freedom is 2.
Maximum no. Will it be a single component system? अगर single component system रहा और अगर एक phase में exist कर रहा है तो कितने degree of freedom लगेंगे?
2.
बराबर 2 लगेंगे. But condensed phase rule किसको बोलते हैं?
F is equals to C minus P plus 1.
F is equals to C minus P plus 1. May I know who is answering?
Rehan Ahmed.
Rehan, can we say condensed phase rule is F is equal to C minus P plus 1. तो क्या ये one component systems के लिए applicable है?
नहीं मैम, 2 के लिए.
Yeah, this is applicable for two component systems. And why we say it as a condensed phase rule? Can anyone else answer me?
Pressure is fixed in.
Pardon? बोलो.
प्रेशर फिक्स होता है. 1 atm पे प्रेशर फिक्स किया रहता है. हमें टेम्परेचर एंड कंसंट्रेशन डिफाइन करना है डिग्री ऑफ फ्रीडम की.
हम प्रेशर को कांस्टेंट पकड़ते हैं और हमें बाकी जो दूसरे डिग्री ऑफ फ्रीडम है उनको डिफाइन करना पड़ता है. एम आई राइट प्रणाली? आप ही आंसर दे रही थी ना?
यस मैम.
ओके राइट. बट हम प्रेशर को क्यों फिक्स करते हैं? उसके पीछे का क्या है?
अगर डिग्री ऑफ फ्रीडम मतलब उसमें कंसंट्रेशन, टेम्परेचर एंड प्रेशर अगर रहा, तो जो ग्राफ हम ड्रॉ करते हैं तो उसमें वो 3D स्ट्रक्चर हो जाएगा और हमें वो डिफाइन करने के लिए इजी नहीं रहेगा. इस वजह से हमने प्रेशर डिफाइन किया है, प्रेशर फिक्स किया है और हमें कंसंट्रेशन एंड टेम्परेचर डिफाइन.
वेरी गुड. बिकॉज अगर हम एक को कांस्टेंट नहीं पकड़ते, एक को फिक्स नहीं करते हैं, so we have to draw a phase diagram which will be a 3-dimensional structure, and we cannot represent that structure on our plain paper or in a planar figure. That's why we consider that we are always working under 1 atmospheric pressure. That's why we fix we consider pressure to remain constant throughout the study, and only the other variables are varying, and that's why we call them it as a condensed phase rule. और जो हमारा phase rule रहता है, इसमें हम 1 degree of freedom हमने automatically fix कर दी है. We are considering it to be constant. That's why the equation is reducing to F is equals to C minus P plus 1. बराबर? That's why it is called it as a condensed phase rule. Now, condensed phase rule is applicable for 2-component system having partially miscible liquids, or it is applicable to 2-component system having partially miscible solids and liquids. जो हम देखेंगे, we will be talking about it after liquid phenol water system. Now, कल हमने चालू किए थे, we are talking about 2-component systems containing liquid phases. Now, when we are talking about 2-component system containing liquid phases, these liquids are partially miscible with each other. They are not completely soluble in each other. They are not completely insoluble in each other, but they are partially soluble in each other. An example is phenol and water system. यहाँ तक समझा था सबको?
Yes ma'am.
Yes.
Yes,
Now,
Yes,
again
ma'am.
write down question. ये बहुत important question है, आता है पेपर में. कई बार आता है explain condensed phase rule with example. ओके अगर ये क्वेश्चन आता है 10 मार्क के लिए, एक्सप्लेन कंडेंस फेज रूल विद एग्जांपल, आप लोग फिनॉल वाटर सिस्टम का एग्जांपल लिख सकते हो या यूटेटिक मिक्सचर्स का एग्जांपल लिख सकते हो, बट बेस्ट इज टू राइट फिनॉल वाटर सिस्टम बिकॉज इट इज इजियर एज कंपेयर टू योर यूटेटिक मिक्सचर्स. नाउ व्हेन वी टॉक अबाउट फिनॉल वाटर सिस्टम, वी नो दिस इज कॉल्ड एज, अब ये रटा गया होगा आप लोगों को, यू मस्ट हैव मेमोराइज इट. This diagram is called as
phase diagram.
phase diagram.
phase diagram, because we are plotting 2 degree of freedom against each other, that is temperature and pressure. Okay, now if it is a 2-component system and if we want it to exist as a single phase, अगर हम normal phase rule apply करते हैं, we require 3 degree of freedom. We should have explained the effect of pressure also, but we are considering and we are always working under 1 atmospheric pressure. So pressure is considered to be fixed. It has got fixed, and now the 2 variables will be temperature and the concentration of phenol in water. Now when we are plotting temperature of concentration against we are plotting temperature against concentration of phenol in water, you will get a curve which is looks like an inverted U curve which is having the boundary. You can see it on the graph. आप लोग को graph clearly visible है?
Yes ma'am.
Diagram clearly visible to you? Okay.
Yes ma'am.
Now आप notebook लिख के लेके रखो, कुछ points आपको लिखने हैं जो मैं बोल रही हूँ. Okay. Now this graph has, कोई भी अगर screen touch कर रहा है तो please मत करो. Okay, this graph has a boundary G, B, H, C, I. Okay, so this graph is having a boundary G, B, H, C, I. Outside this boundary, the system will be 1 liquid phase system. Inside this boundary, अगर इसके अंदर का हिस्सा देखते हैं, the system will be 2 liquid phase system. It will be existing as 2 phases. One will be water phase, another one will be phenol phase. Phenol is heavier than water. तो आपको ये ग्राफ में, ये फेज डायग्राम में टेस्ट ट्यूब बनी हुई दिख रही है?
Yes.
Yes, you can see test tube. Okay, now we are increasing, if you see, we are increasing the concentration of phenol in water. If we are talking about in the x-axis, just see the markings, just see the scales. The scale is from 0 to 100, right? All of you can see it?
Yes.
Yes, ma'am.
It is 0 means it is 100% water with 0% phenol. ठीक है? समझ में आया? When we are talking about 0, it means it is 0% phenol and 100% water. अगर आप other end of graph या phase diagram में जाओगे, it is talking about 100. Okay, it means 100% by weight of phenol, which is containing 0% water. This much is clear?
Yes, ma'am.
Yes.
Okay. And if you see on the temperature scale, the temperature is given in Celsius. Okay, this scale will be ranging from 0 degree to 100 degree. Fine. Concentration is by percent weight by weight. Percent weight by weight कैसा रहेगा? Suppose if I say it is containing 5% weight by weight of phenol in water. इसका मतलब क्या हुआ? It will be 5 gram of phenol in
5 grams.
95
5
gram
gram of water.
95 gram of water.
95.
बराबर. So it is
Yes,
making 5% weight by weight of phenol. So here what is happening, the concentration of phenol we are slowly increasing. Initially अगर आप ये test tube A देखते हो, can you see the test tube which is marked as A?
Yes.
Yes, ma'am.
Yes. This test tube is containing 100% water. 100% by weight of water but 0% by weight of phenol. Pakka?
Yes.
Yes, ma'am.
So it will be a biphasic system or a single phase system?
Single.
Single phase. It will be a one liquid phase because it is pure water. Now, what is done in phase diagram, how this phase diagram is studied and how we do the experiment of phenol water system is, we increase the concentration of phenol slowly in the test tube. Okay, and we maintain the system at a constant temperature. क्या करना है? Test tube में पानी लेना है. First it will be 100% water and increase the temperature to 50 degree and maintain the temperature to 50 degree throughout the study. Okay, so can you see the line on the graph B to C? This line B to C?
Yes, ma'am.
Yes. Now this line is line which we call it as a tie line. T-I-E-L-I-N-E, tie line. Always the tie line is parallel to the x-axis. The tie line is parallel to x-axis, and by working on tie line, we can determine the different concent or the various concentration of the phenol in water or water in phenol. Okay, अभी हम वो डिटेल में स्टडी करेंगे. सिर्फ ध्यान रखो, this graph phase diagram is having a curve. This curve is defined by GBHCI. Outside this curve, the system will be one liquid phase system. Inside the curve, the system will be two phases liquid system. Okay. When we are doing the study, we are studying the liquid water system. We are studying liquid water phase rule at 50 degree. We are maintaining the temperature throughout the study at 50 degree. Okay. जब हम 50 degree पर study कर रहे हैं, you can find that till if you are seeing this graph, अगर आप point G तक देख रहे हो, okay. अब अगर आप G से point B पर जाते हो, what is happening in the system? आप देख रहे हो नीचे आपको टेस्ट ट्यूब में थोड़ा सा ब्लैंक व्हाइट दिख रहा है, ऊपर ऐसी क्रॉस लाइंस लगी है, बराबर?
Yes, ma'am.
Right. It means at point B, what is happening as you are slowly increasing the concentration of phenol in water, a point will come. This point will be point B, where phenol will not be miscible with water and it will separate out into two phases. Bottom phase will be phenol phase because phenol is denser, and upper phase will be water phase because water is lighter than phenol. यहाँ तक समझा?
Yes.
Okay. Now, if you see the concentration, अगर आप B point को अगर extrapolate करते हो, मेरा cursor दिख रहा है?
Yes, ma'am.
Yes, ma'am.
3 point को अगर आप extrapolate करते हो x axis पर, you will find that the concentration of phenol will be 11% weight by weight. Okay, इसका मतलब क्या हुआ कि 10%, 10.5, 10.8, 10.85, 10.9% वेट बाय वेट फिनॉल तक के सिस्टम सिंगल फेज सिस्टम रहेगा. बट जैसे ही आप 11% फिनॉल डाल दोगे टेस्ट ट्यूब में, व्हाट विल हैपन? नाउ द सिस्टम विल नॉट बी अ सिंगल फेज सिस्टम, इट विल बी a biphasic system. It will be having two phases. Okay, नीचे वाला फिनॉल फेज रहेगा, ऊपर वाला वाटर फेज रहेगा. अब ये जो वाटर फेज रहेगा, this water phase will not have any concentration of phenol. क्या लगता है आप लोगों को? Will this water phase will have certain percent of dissolved phenol in it?
Yes.
No.
It
No,
will
ma'am.
have certain percent of
Yes,
dissolved
ma'am.
phenol in it, and this concentration is found to be 11%. You are getting my point?
Yes, ma'am.
Okay.
Yes, ma'am.
As you keep on increasing the concentration from point B to point D, अगर आप point D पर जा रहे हो, आप 11% से ज़्यादा phenol ले लिए, it is somewhere about 22 or 23% of weight by weight of phenol in water. What will happen? Again, the system will separate out into two phases. It will be the upper phase will be water phase, which will have 11% of dissolved phenol, and the lower one will be the water phase. Even water phase, phenol phase. Upper one will be the water phase, which is having 11% of dissolved phenol, and the lower one will be phenol phase, which will be having 63% of weight by weight of phenol. Because अगर आप इधर जाते हो, you come to the point C. Can you see point C on the graph?
Yes.
Yes. Point C is containing 63% weight by weight of phenol in water. Okay. अब जैसे 63 से अगर आप 64 या 65 या 67% पर जाओगे, तो what will happen?
The
From 63% आपने 67% phenol डाल दिया water में. Again the system will start existing as a single phase system. Okay, so if you want water phenol to exist as a one phase system, either the concentration of phenol
lower than 11%,
less than 11%, or it should
greater
be
than 63%.
63%.
11% और 63% के बीच में जो भी concentration रहेगा, whatever the concentration will be there between 11 to 63%, it is always going to make the system as a
Two-phase liquid.
two-phase system. This is at what temperature?
50 degree.
50 degree.
50 degrees.
Okay, now suppose अगर हमने point, again you consider point D. Okay, you consider point D, where the phenol was, say for example 23% weight by weight of phenol in water. 23% weight by weight of phenol है water में, यानी remaining 77% will be water.
Yes.
Yeah.
Yes,
Now
ma'am.
if you slowly increase the temperature, you take the temperature to 60.8 degrees Celsius. What will happen? Can you see the point H on the graph?
Yes.
Yes,
Yes,
ma'am.
ma'am.
What will happen when the temperature is coming to 66.8?
Then it is one liquid phase.
It will start becoming a single liquid phase. Okay, अगर आप 66.8 या 66.9 पर जाते हो, the system will become a clear system. Though the concentration of phenol in water is how much? For example, 23% weight by weight of phenol is there in water. Ideally, 23% weight by weight of phenol in water is immiscible. Okay, it is either the concentration of phenol should be less than 11% or it should be more than 63%. मगर आपने रखा 23%, but क्या किया? 50 डिग्री के बदले आपने टेम्परेचर इंक्रीज कर दिया 67 डिग्री पर. 67 डिग्री पर क्या हो रहा है? The system is started existing as a one liquid phase system. So this point H, or this 66.8 degrees Celsius, is the upper consolute temperature of water phenol system. Okay, upper consolute, CONSOLUTE, consolute temperature of water phenol system. You are getting this point? This
Yes,
upper
ma'am.
consolute temperature of water phenol system is also known as critical solution temperature. उसको और क्या बोलते हैं?
Critical
It
solution
is also
temperature.
called as critical solution temperature, or it is known as upper consolute temperature. And if you are taking a pure phenol, this temperature will always remain to be 66.8 degree. जैसे ही 66.8 degree आएगा, system will become a single phase system. जैसे ही आप cool करोगे, 66.5 पर लेके जाओगे, the system will start appearing as a biphasic system. Okay, so how we can define critical solution temperature?
At a
Thank you,
constant
Satya.
temperature.
Huh?
At a constant temperature, the phase will start as a one liquid phase.
Very good. It is the upper consolate temperature is defined as the temperature above which the system will start or system will exist as a single phase system. Okay, it is called as upper consolute temperature, or it is called as the critical solution temperature. यहाँ तक समझा सबको?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
ठीक है. Now when we are ये again definition आता है define upper consolute temperature. कई बार fill in the blanks में आता है the upper consolute temperature of water phenol system is dash. So you have to write it is 66.8 degree Celsius. Okay. Again we will come back to this line B and C. This line BC is called as
Tie line.
tie
Parallel.
line. Now this tie line has got a very important function. अगर आपको concentration पता नहीं है, आपको दो unknown concentration phenol और water का मैंने test tube में बना के दिया, what you can do by working on the tie line, you can find out the composition of each phase. अब आप जब बोलते हैं composition of each phase, for example E देखिए. Okay, it is almost containing, we can say 50-50% पकड़ लो. 50% by weight is phenol, 50% by weight is pure water. Okay, अब now this 50-50% is there. अगर ये दोनों separate out होंगी, you can find out what will be the, you can find out by calculating on the tie line what will be the weight of the water layer, what will be the weight of the phenol layer, and how much amount will be dissolved, phenol dissolved in water layer, and how much of the phenol will dissolve in the phenol layer. Because we know normally when we are talking about phase rule and when we are working at a constant temperature of 50 degree, we know water phenol will separate into two phases if it is containing 50% by weight by weight of phenol in water. Okay, जब ये phenol in water में separate हो रहा है, नीचे की layer कितनी percent है? 50% phenol है.
50%.
but ये 50% में कितना phenol है?
5%.
63%.
63%.
You got it? It will be
Yes, ma'am.
63% and remaining will be water.
Water.
सिंगल फेस बना रहे हैं दोनों भी, बराबर. तब हम उनको सेपरेट नहीं कर पाएंगे. अगर ये इमिसिबल लिक्विड होते तो हम बोल सकते थे कि ऊपर वाला लेयर इज 50% वाटर, नीचे वाला लेयर इज 50% फिनॉल. तब हम बोल सकते थे, बराबर.
Yes, ma'am.
Yes, but now it is a partially miscible liquid, so now we cannot say that the upper layer is 50% pure water and the lower layer is 50% pure phenol. No, it is not like that, because the upper layer will have how much percent of phenol dissolved in it?
63%.
No, water layer will have how much percent? Upper layer is water layer. Okay, upper layer is less denser layer. Phenol is denser than water, so it will form a bottom layer. Upper layer is water layer. So this water layer will have how much percent of dissolved phenol in it? 11%.
11%.
Right? And the lower layer will have how much percent of dissolved phenol in it?
650.
63%.
Okay. So ये जो दो liquid separate हो रहे हैं, जो दो layer separate हो रही है, this layer we call it as a conjugate liquids. What we call them?
Conjugate liquid.
We call them it as a conjugate liquids, and by finding out the ratio of conjugate liquids, we can actually find out how much is the amount 5 ग्राम है, 2 ग्राम है, 3 ग्राम है या 1 ग्राम फिनॉल डिजोल्व है कौन सी लेयर में. ओके, that we will not go into detail, वो required नहीं है आप लोगों को, but you understand the what is the application of phase rule. Application of phase rule lies in the calculation of how much amount will be dissolved in which layer. Okay, you can actually find out how much amount of phenol will be dissolved in each conjugate layers. Because अगर आप water phenol system देख रहे हैं, say take point F. Okay, this point F will be having something more than 50% of phenol in water. Okay, so this is if it is getting separated out into two conjugate liquids. Because why two conjugate liquids? Because it is a biphasic system and these two liquids will not be miscible with each other. Okay, so upper layer is always going to have 11% of dissolved phenol by weight and the lower layer will always have 63% of dissolved phenol by weight. पक्का यहाँ समझा?
Yes, ma'am.
Okay. Now if you go beyond point C, अगर आप ये वाला टेस्ट ट्यूब देखते हो तो क्या हो रहा है? Your concentration is
phenol is increases. Phenol rather रहेगा.
In higher concentration, water का concentration कम हो गया है. Okay, it is almost 80% by weight of phenol is there in this test tube. It means this is going to make a single phase liquid. ये समझा सबको?
Yes, ma'am.
Okay. Now, if we talk about water phenol system, when we talk about phenol, any idea phenol room temperature पर कैसा दिखता है? Pure phenol I am talking about. If we keep phenol at room temperature, is it in liquid state or it is in solid state?
Liquid.
Liquid. Any other answer? At room temperature, phenol exists as a crystalline solid. Okay, pure phenol at room temperature is crystalline solid. So if we want to handle it as a liquid, we have to melt it. Okay, तो अगर पोछा लगाना है और प्योर फिनॉल का पोछा लगाते हो, 100% फिनॉल का पोछा लगाते हो, what is the nature of phenol? If it is used as a disinfectant for cleaning your floors, if you are using pure phenol and if it comes in contact with the skin or body, what is the nature of phenol?
Highly toxic.
It is highly corrosive, highly corrosive. I have seen it in the laboratories also. अगर if you people students are not paying attention, if the test tube break opens, पूरी skin जल जाती है, full skin white हो जाती है, and severe burning you get it. Okay, it is a highly corrosive material, so we cannot handle it in the pure form. So we have to make it in a form in which it will be in the soluble state. तो कौन सी soluble state में? और हमको hazy liquid भी नहीं देना है. कई बार लोगों को लगता है पता नहीं क्या impurity है. If it is in hazy liquid, so what we can do? Either we can make a phenol liquid system as a single phase system having concentration of phenol less than 11% or having concentration of phenol more than 63%. Okay, this is clear?
Yes, ma'am.
No doubt in this. Now how we do the experiment of this? Okay, now I have written the definition. एक बार यहाँ देख लो. The maximum temperature at which the two region exist or two phase region exist is known as critical solution temperature or upper consolute temperature, and the temperature above which when the single phase will appear, even that temperature is called as upper consolute temperature. And for water phenol system it is 66.8 degree Celsius. यहाँ तक क्लियर है?
मैम एक बार पॉइंट इसको बताओ ना एक बार ई का
क्या?
थोड़ा एक बार पॉइंट ई एक बार वापस समझाइए ना.
पॉइंट ई पर क्या हो रहा है? सपोज अगर ये ग्राफ में देख रहे हैं आप, 1 सेकेंड मेरा, ओके, पॉइंट ई देख रहे हैं. सपोज ये कर्व में अगर देख रहे हैं, इट इज कंटेनिंग 40% वेट बाय वेट ऑफ फिनॉल. ओके, इसका मतलब क्या हुआ? 60% वाटर है, 40% फिनॉल है. ओके, नाउ इफ वी आर कीपिंग द सिस्टम, ये टेस्ट ट्यूब को अगर हम 50 डिग्री पर रख रहे हैं तो दे विल नॉट बी एग्जिस्टिंग एज अ सिंगल फेज सिस्टम, दे विल बी एग्जिस्टिंग एज अ biphasic system. Now what will happen? As we are keeping this test tube at 50 degree, the system अगर हम थोड़ी देर undisturbed रखते हैं, two phases will separate out. One will be the lower phenol phase and the upper one will be the water phase. Okay, अब ideally क्या है? 60% water phase, it is not 60% pure water phase, बराबर. It is
Yes,
having
ma'am.
11% weight by
Percent.
weight of phenol dissolved in it, and this 40% is not pure phenol phase. It is containing 63% weight by weight of phenol dissolved in it. Okay, and ये जो दो layer separate हो रही है, the upper layer that is the water phase containing 11% weight by weight of dissolved phenol, and the lower phase containing 63% weight by weight of phenol. These two layers are known as conjugate liquids. They are called as conjugate liquids of each other. Okay, and by working on the tie line, we can find out the proportion, we can find out how much is the amount of phenol dissolved in each layer. This is clear?
Yes, ma'am.
Okay, now next point. If we are saying if it is a pure phenol, the upper consolute temperature or critical solution temperature of water phenol system is 66.8 degrees Celsius. Imagine करो गलती से मैंने पानी की जगह नमक का पानी ले लिया. Okay, instead of taking water, I have taken the water or the salt water, that is sodium chloride dissolved in it. What will happen to the upper consolute temperature? Apply your logic and tell me what will happen to upper consolute temperature. What is the nature of sodium chloride?
Mm,
सोडियम क्लोराइड कौन सा टाइप ऑफ कंपाउंड है? We call it as a salt, right? Arey, answer me. Can you
Basic.
hear me?
Ionic.
It's an ionic compound. It is having sodium ions and chloride ions. Barabar?
Yes.
Now, polarity of sodium chloride is more or it is less? Am I audible?
Yes.
Yes or no? Am I audible?
Yes, ma'am.
Ma'am.
Now tell me,
Yes,
what
ma'am.
is the polar nature of sodium chloride?
High.
High. What is the polarity of water? आप लोग ने डाइलेक्ट्रिक कांस्टेंट वर्ड सुना है?
Yes,
Yes, ma'am.
Yes, ma'am.
डाइलेक्ट्रिक कांस्टेंट कितना रहता है?
18.
आइडिया मत दो, एक रफ फिगर बोलो, कितना रहता है?
81 होता है.
कितना होता है?
81.
ओके, 81 नहीं होता, वी कैन से मोटा मोटा पकड़ लिए तो 78 79 होता है. बराबर, राइट, यू आर राइट. सो it is if it is having a high dielectric constant, it means what type of solvent it is? Polar or non-polar?
Polar.
What is the nature of the substance
Polar.
we have added? Sodium chloride?
Polar.
Polar. What is the nature of phenol? Phenol, I am not very good in chemistry, मेरे को 26 साल हो गए छोड़ के, but if I am not wrong, phenol का जो structure है वो benzene ring है और एक OH group attached है. बराबर?
Yes, ma'am.
Yes.
So tell me, what is the polarity of phenol? Can we call it as highly polar molecule or not?
No.
No.
It's not a polar molecule. We still
Non-polar.
consider phenol as a non-polar molecule. बराबर?
Yes.
जो भी polarity आ रही है वो कौन से ग्रुप्स की वजह से आ रही है?
OH.
OH की वजह से आ रही है. अगर फिनॉल वाटर में स्लाइटली मिसिबल है तो किस वजह से मिसिबल है? Because this OH group of phenol कौन सा बॉन्ड बना रहा है वाटर में?
Hydrogen bond.
Hydrogen bonding.
बराबर, इसलिए वो पार्शियली मिसिबल है. और अगर बेंजीन होता तो क्या होता था?
Immiscible.
It will be having just a cyclic structure बेंजीन का, और वो कोई भी फंक्शनल ग्रुप नहीं था, पोलर फंक्शनल ग्रुप, जिसकी वजह से वो हाइड्रोजन बॉन्ड बना सकता, इसलिए इट वाज इनमिसिबल. बराबर.
Yes.
Now when we talk about solubility, our solubility rule, जो general rule है, what we consider like dissolve life. बराबर, ये सुना है आप लोगों ने?
Yes, ma'am.
अब सोडियम क्लोराइड डाल दिए आपने, सपोज पानी की जगह आपने थोड़ा सोडियम क्लोराइड, गलती से नमक गिर गया, सॉल्ट गिर गया. What will happen to upper constituent temperature? That is my question.
Ma'am, temperature rises.
के बढ़ जाएगा.
बढ़ेगा.
Ma'am, rises.
It will rise. Very good. बढ़ेगा. क्यों बढ़ेगा?
Ma'am, temperature fluctuation हो जाएगा.
ओके, अब मैं एक आपको एग्जांपल देती हूँ. आप सभी ने थम्स अप, कोका कोला पिया होगा.
Yes.
Am I audible?
Yes, ma'am.
Yes, ma'am.
All of us drink cold drinks, थम्स अप, कोका कोला, ओके, या सोडा. अगर सोडा में नमक डालो तो क्या होता है? कभी डाला है थम्स अप की बोतल में नमक?
नो
अरे
No.
ऐसे
कार्बन डाइऑक्साइड डिजॉल्व हो जाती है.
क्या? हाँ, क्या होगा?
गैस बाहर आती है.
अभी कभी जब पूरा लॉकडाउन
कार्बन डाइऑक्साइड डिजोल्व हो जाएगी.
ट्राई करके देखना, वो पूरा फिस करके बाहर आता है, बराबर.
यस.
जैसे ही नमक डालोगे आपको ऐसा लगेगा कुछ फिस जैसा, बबल्स बबल्स करके बॉटल में से बाहर आएगा, और थोड़ा कोक पानी, कोक बॉटल के बाहर गिर जाएगा. ओके, नाउ व्हाट इज हैपनिंग हियर? व्हाट इज हैपनिंग हियर? क्या हो रहा है? Now when we say Coca-Cola or Thumbs Up, it is having which gas dissolved in water? Come on, answer. Am I audible? Am I audible to all of you? Am I audible? Someone answer me.